Okay, now that we've gotten starter into a structure that's a little bit better for presenting multiple trials, we're not presenting multiple trials yet, but we've got it in that structure now. We have a separate function called trial. Here you see the function prototype right there, and down here the actual trial. All that is fantastic. Now I want to get into timing for just a little bit, because right now we're timing in a very crude way using the all rest function. And the all rest function, it's handy every once in a while, but the problem with it is you can't do anything inside of it. In other words, if you want to rest for 10 seconds and wait for the subject to respond, you can't collect the response. So we need a way of timing that will actually allow us to do things while we're timing the stimuli. Another thing that you can't do in all rest is break from the rest. So if you decide, well, okay, now I know my program works, let me get out of this and keep working on it, you have to wait till the rest is over. You can't just get out of it. So we're going to learn a little bit more sophisticated way of timing now. And the way we're going to do that is with an Allegro function called allGetTime. All right, so one of the first things we need to do in order to make this work is we're going to need a couple of doubles, double variables. So we're going to define a double called start time and another called stimulus duration. Now, once you get used to programming, you can kind of abbreviate some of these things like start t or stimulus dur, that sort of thing. But for now, I'm going to try to spell out as much as I can so that we remember what these things are doing for us. Okay, so we need to put in those a couple of doubles. And of course, at least one of these we're going to need to define, which is stimulus duration. How long do we want this to go on for? And we're going to make it go on for 1 second, same amount of time that you should have your rest for. I have mine for 10 seconds right now so that I can drag it over from the other screen, but you should probably have a 1 here in the all rest. Okay. The next thing we need to do is set our right after we flip the display here, I'm going to get rid of the all rest here. I'm going to go ahead and delete it. And right after we flip the display of the circle itself, I am now going to set the start time to that Allegro function, all get time. Now let me talk a little bit about all get time. All get time is constantly updating with the number of seconds, and it is a double floating point integer, or double floating point variable. It is constantly updating the number of seconds since the Allegro was initialized. So back up here in our main program, right here, this command, all init. Since that got called, all get time has been incrementing, counting the number of seconds. And the accuracy, the makers of Allegro claim that it all depends on your operating system and what else you have going on your system and stuff. They claim it can be down to microseconds. I don't know if that's true or not, but I have not taken out an oscilloscope and measured it on my system, but it's certainly, I think, well within the microseconds, well within the millisecond range. Like within a couple of milliseconds, it seems to be pretty accurate. So we're going to set our start time to equal get time, and now we are going to set up a while loop. While all get time minus start time is less than stimulus duration. Now let's go through this and see what it's doing. Remember, all get time is constantly changing. It's constantly incrementing, getting bigger and bigger with the passage of time. So it's basically like a clock. It's a clock, and it keeps going, keeps tracking time. But here, with this statement, start time equals all get time, we have frozen start time at the value of all get time at that instant when this thing gets called. So start time is just sitting there at whatever number it was set to up here, while this one is changing, and they're just getting further and further apart. The distance between them is just growing and growing up into what we have defined as the stimulus duration. And as soon as this difference between all get time and start time exceeds the stimulus duration here, this statement becomes false and the while loop stops. Okay, and so now down here, our open and closed curly brackets. You can actually leave them like that if you're not going to do anything inside of them. I'm going to go ahead and hit enter because eventually we will start putting stuff inside there, stuff that we're going to do while this stimulus is still going on. But for now, that'll do it. Okay. And now this should function, I believe. Let's try it and see if I've forgotten anything. Yep. Oh, yeah, and you saw how quickly it went away because I actually did set stimulus duration to 1. Let me set it to 2 just to give myself a little bit more time to grab it from the other screen. There it is. And so you can see there, it times it, and then it goes away exactly when it's supposed to. Okay, so that's how timing works, and that's going to work for a lot of things that we time. Every once in a while, like I say, it's more convenient to use the all rest, but for the most part, using a while loop and all get time is the way to time stimuli, because then you don't have to give up doing other things during that time. You can still be doing them inside this while loop. All right, I'm going to go ahead and stop it there, and I'll see you on the next one.